Speech number 3. Here's my license. Where is my people? In the mid-20th century, black holes were a thing of myth among the world's leading astrophysicists. That was until the late 1960s when Roger Penrose and Stephen Hawking developed a mathematical proof that showed that black holes exist. The proof used Newton's theory of relativity. With the discovery of the black hole, the world was alight with black hole fever. While the math is complicated, the proof is irrefutable. Black holes exist, and they are awesome in their powers. But what are black holes? How powerful are they, and how can we see them? The first issue that we want to discuss is what are black holes, and how do they form? A black hole was a star at one time. As the star consumed the material around it, it grew and it grew and it grew until it could no longer sustain its own weight and it collapses. The collapsed star then forms the core of the black hole. The core of the black hole is among the densest, heaviest matter in all the universe. This leads to the question of power. How powerful is a black hole? Well, Newton tells us that gravity is directly proportional to mass, and a black hole is no exception. A black hole has the strongest gravity in all the universe. The gravity is so strong that not even light can escape, hence the name black hole. Many astrophysicists have wondered what happens to all the matter that is eaten by a black hole. One theory is that the matter travels through the black hole and into a parallel universe and exits out of what's been dubbed a white hole. While there's absolutely no proof to this theory, there's nothing to disprove it either. Other astrophysicists believe that the matter becomes part of the core of the black hole. This theory might actually have some merit, because Stephen Hawking developed another mathematical proof that could possibly account for this possible phenomenon. I bet by now you're wondering, how can we view a black hole? It's actually impossible to directly view a black hole, but there is two ways you can observe a black hole. The first way to observe it is to observe the effect its gravity has on the surrounding planets. The best way to do this is by a binary star system. A binary system is two bodies rotating around a single point. If one of those bodies happens to be a black hole, then it will appear as though one planet is rotating around the point itself. The second way to view a black hole is to view it when matter is eaten by the black hole. While from Earth this looks like it happens very slowly, it actually occurs in an instant. Keith Holliday's book, Introductory Astronomy, says that the intensest gravitational field in a black hole is around the event horizon. Any matter that accelerates into the event horizon accelerates at very high speeds, thus heating it and creating a molten plasma. The result is radiation that's emitted from the heat. This radiation falls within the X-ray area of the electromagnetic spectrum. We can view this radiation using radio telescopes. The event horizon, as explained in Exploration of the Universe, is the point at which no matter or light can escape the black hole. Nothing in the universe can reach a high enough speed to match the black hole's escape velocity. Escape velocity is the speed at which matter needs to travel to overcome a place's gravity. For instance, the escape velocity of Earth is 7 miles per second. What this means is that if you stood on Earth and fired a bullet straight up into the air, that bullet would have to go 7 miles per second to overcome Earth's escape velocity. Black holes are very intricate and complicated celestial bodies. However, they continue to inspire the imagination of all the world's people. Astrophysicists have just begun to understand the intricacies of a black hole. While a human being will never be able to see the inside of a black hole, astrophysicists will continue to investigate this phenomenon.